Hi students, let's talk about collisions between two balls. What governs the outcome? Of course, PCOM has a say in this. Because it's just the two of them pushing each other, we know that the total momentum must be conserved. Take for example, the collision between two balls of the same mass m, same speed u, in opposite directions. In other words, total momentum is zero before the collision. This means that the total momentum must remain as zero after the collision. So is the outcome going to be this? Maybe, possibly. But this outcome is also possible. And so is this one. And this one. And this one. All of them have total momentum of zero. All of them fulfill PCOM. All of them are possible outcomes. So what's going to determine which of these outcomes is going to be the actual outcome? We have been talking about the momentum, but what about the KE? The one at the top has the same total KE as before the collision. Going down the rows, the collisions are losing more and more KE. The one at the bottom actually lost all the KE. But wait a minute. Must KE be conserved? What does PCOE have to say about this? PCOE says that the energy can be converted from one form to another as long as the total energy is conserved. So during a collision, KE can be converted into other forms of energy, like heat, sound, bond energy, etc. That's why we also have to talk about the elasticity of a collision. An elastic collision is one that retains 100% of the total KE. An inelastic collision is one that loses a fraction of the KE into other forms after the collision. A completely inelastic collision is one that retains the least possible amount of KE after the collision. Some balls are just bouncier than others. Elastic collisions tend to occur with hard and stiff objects. Inelastic collisions tend to occur with soft and malleable objects. Coming back to this, all these are possible outcomes that fulfill PCOM. Which is the actual outcome depends on the elasticity of the collision. If it's between two billiard balls, the outcome is more likely to be elastic. If it's between two plasticine balls, then the outcome is likely to be inelastic. Got it? Let's look at another example. A collision between two equal masses m, one with initial speed of u and the other initially at rest. These are just 5 out of all the infinite number of possible outcomes. Notice that momentum-wise, all of them have the same total momentum of 1 mu before and after the collision as dictated by PCOM. But KE-wise, the elastic collision retains 100% of the initial KE, whereas the perfectly inelastic collision retains only 50%. Some students ask, shouldn't the perfectly inelastic collision result in both balls losing all KE and coming to rest after the collision? Use your brain. Make sure you can answer this question. I gotta go. Ta-ta!